So before we start diagnosing whether we're in control or not, we need to make sure that we have enough data to be significantly significant. The general rule is that we want to have at least 50 observations, and we need to group them into groups that have at least 4 observations in a group. So once we have enough data, we can use the fact that we know how likely it is that something is outside of a warning limit or outside of an action limit to make some rules for how we decide is the process in control or not. So the first 2 rules that you see here are derived exactly from those odds. We haven't seen 1,000 observations, so nothing should be outside of the action limits, and no more than about 1 in 40 values should be between the warning and action limits. The third rule is paying attention to the fact that if you have 2 consecutive things outside of the warning limit, the probability of the first one being there is 1 in 40, and the probability of the second one being there is 1 in 40. And the probability of both of them being there is the product of that, which is about 1 in 1,600, which is highly unlikely if we're in control. Similarly, the last 3 rules are also specifying things that are highly unlikely if our process is in control. In these rules, a run is a sequence of points that have approximately about the same value. And a trend is a sequence of points that is going either increasing or decreasing. If we see a run or a trend of 5 or more groups that is touching a warning or an action limit, or there is a run of 6 sample means that are on the same side of the grand mean, or if there's a trend of 6 values of sample means that is either rising or falling, those are all situations that are highly unlikely if our process is in control. So if we see them, we're going to assume that the process is not in control. While we're making all this excitement about being in control, it's important that we pay attention to exactly what in control means. In control means that things are reliable and reproducible, but it does not mean that we are meeting the requirements of the process. So our control limits have been derived from the data that we have observed about the process. But specification limits are what the process must meet in order to be successful. So only once the process is in control, then we can compare the control chart limits to the specification limits to see if the process is capable of meeting those requirements.